Hey everybody, this is Brian, and welcome to the 16th Python tutorial. Today we're going to be covering binary files. Originally I was going to split this up into two videos, but I think I'm just going to do one just to make it a little faster. If you're wondering what a binary file is, it's a computer file that is not a text file. That's the very descriptive Wikipedia article right here. What does that mean exactly? Well, a text file is meant for humans to read and write. I'm sure you've opened like gedit or notepad or text on Mac or whatever, and you've just written yourself a quick note and saved it. Well, if you examine the contents of that file, it looks exactly how you typed it. That's a text file. A binary file would be like, well, an image or a database or this web browser, any executable, or any type of file you can imagine. And here's an example of what it might look like in a hex editor. You can see their hex values. And it gets pretty complicated, and there's some computer classes you should probably take, like you should learn like what a bit and what a byte is and what a nibble and all that stuff, but we're not going to really cover that because I don't want to bore you with the details, and if you're watching this video, you probably already know what they are. So if not, you can go out and just learn on your own. Google's awesome like that. We're going to call this the very descriptive video 16. And we'll call this binary files. So why would you want a binary file? Well, let's say we have a list. And in that list we have some numbers. Let's just say 12, 30, 34, whoops, 34, say 200 and 255. That's our list of numbers. And we want to write those numbers to a file. And we want to be able to read those numbers back exactly as they are. Well, we're going to make our string literal here, and I know the path to my directory. I'm going to name this test.txt. Now I know somebody out there is like, whoa, hold the phone here. Test.txt, isn't that a text file? Actually, no. The extension does not denote what type of file it is. It's just a name. The contents of the file are, well, up to you. Typically, you'll get what's called a header inside of a file. And let's just, for whatever reason, say this is the header. So if you ever open like a JPEG or a bitmap or something in like Notepad, you'll actually see the header. It'll say like, image dash JPG or whatever. That denotes what type of file it is. So anyways, we're going to make a buffer. We'll call this, we're going to call the bytes function. And what this does is it turns our list into, well, a list of bytes. So we can actually print let's run this and see what happens here. You can see our list looks nothing like what we have up here. It's B and then this little guy and then /XOC. What's going on here? Well, what it's doing is converting it to bytes in memory, hence the little B notation in front of our string. That says this is a byte string instead of a literal string or a real string. And this is hex. If you don't know what hex is, there's a whole science behind it. I won't get into it, but it's just a different way of displaying the number. Like XFF, that's 255. So you can see it gets kind of interesting. Now, let's actually take this, and we're going to write this to a file. We're going to say open, and we're going to say binary write. Very important that you say binary write. If you don't, you may encounter an error. Now we're going to write that buffer out to the disk. Run this again. Process finished. So let's go look at this little guy here. And if I just drag it over here, you see it's got this gobbledygook. What is that? Well, that is the, in my case, gedit. Yours might look drastically different depending on what you're really looking at. It's going to base on character encoding. Well, I was trying to get it changed, but it didn't. But anyways, it may display it differently. It may show like a little happy face or like a little Y with 2 dots over it or whatever. But that is an example of a binary file. You're not meant to read this as a human being. This is strictly for the computer. So if you've never seen a binary file, congratulations, that's your first. Now we're going to actually read it back. And this is why I was saying I'm just going to do it in one video, because this was originally going to be 2 videos, and what's the point? So let's actually just print. We're going to read it back. And let's say with and while I'm typing this, I'm just going to open this with binary read. But while I'm typing this, be sure to check out the Void Realms Facebook group. There's over 200 of us in there, and we just try to help each other out. So let's go buffer equal, oops. And we want to read, you can read all of it. We're going to read a maximum of 16 bytes. If you just do read, I think it's just going to read all of it, but I just wanted to demonstrate that you can limit how much you're going to read back. And now we're going to print whoopsie, not doing good today. My brain is just not here. I had a pretty long day at work. I'm sure you guys know how that is. So we're going to take that buffer. Now you may be saying, well, don't you have buffer up here? Actually I do, but I'm changing the variable. Because I'm reading it, I'm replacing it in memory. It's not a popular programming style, but it's actually a very common one. For I am buffer. Now I'm just going to loop, and I'm going to print out. And we're going to do what's called a cast. If you're not familiar with a cast, I think we've covered it in other videos. It's just converting one data type to another. So we're just converting it into an integer and making sure that it's going to display correctly. Let's run this and see what happens. So you see the length of the buffer is 4. We've read the file. Notice how we said read 16. If it was longer than 16, it would chop it off at 16, and you'd only get 16. So if that file had 300 bytes in it, we'd only get 16 because we said limit it. And the length is 4, so we know we got 4, and sure enough, our values are 12, 34, 200, and 255. Now, why would you want to write a binary file? Simply put, you can pack a lot of information into a binary file that you couldn't with a text file. For example, think of a picture. You've got like a 600 by 600 picture. Well, take 600 by 600, that's how many pixels are in there. It takes even more bytes to represent that picture because you've got different color scales, you've got the size of the image, the header, all this information. And it actually gets into what's called a structure, which we're going to cover in the next tutorial, which is a very common theme for binary files. Well, that's it for this tutorial. Pretty painless. Be sure to visit my website, voidrealms.com, for the source code for this and other programs. And go out to Facebook and visit the Void Realms Facebook group.